Let's differentiate this. So the first thing you have to do here is you must realize that you will find the derivative of log base x of pi alone and add it to the derivative of log base pi of x alone. Now, for log base x, we don't have a rule to differentiate this directly. So what we'll do is we will use a log law. Log law that I will write as saying log base a of b is equivalent to ln b over ln a. The law doesn't say this exactly, but it satisfies this. It says for any base, so I'm gonna use ln as my base, as e is my base, so I'm just gonna use in log. So to apply that here, I have d on dx of ln pi, which is my thingy, and then I have ln x, which is my base, because the base has to be on the denominator according to the law, on your log laws. Then here we have a rule for differentiating this, because pi is a constant. So if pi is a constant, we are going to use the differentiation rule for logs. So when you differentiate logs, you put the original function on the denominator and you say in log of the base, and then on the numerator you put the derivative of the original function that is inside the log, and the derivative of x is 1. If you want more information on how to derive logs directly like this, I'm going to link a video on the top right corner of this video. You can go watch it. Now we have this. To differentiate this, we are going to have to use the quotient rule. But what I'd like us to do first is take out ln pi first outside of the differentiation, because it's a constant. You don't have to, but it's gonna make things easier for us. So say ln pi times d on dx of 1 over ln x. Now what I've thought of is rather using the chain rule instead of the quotient rule, because in this case I feel like it's gonna be easier. So what I'll do is I'll say ln pi, which is this one, and then I'll multiply that with d on dx of ln x to the power of minus 1 plus 1 over x ln pi. Now let us do the differentiation here. You differentiate the outside, which is something to the power of minus 1. So that's just the power rule. You say minus 1 times ln x to the power of, you subtract 1 to the exponent, you have negative 2. And then you find the derivative of the inside. The derivative of ln x is 1 over x. And then you add this, which is 1 over x ln pi. Now let's try to simplify this. We have ln pi all divided by, we have x on the denominator, and we have a negative at the top, which we have to deal with, negative 1, and then we have ln x all squared. That's added to 1 over x ln pi. Now the addition here, you'd have to take the LCD. The LCD would be x ln pi ln x squared. That's our LCD. What do you have to multiply this with to get the LCD? It's ln pi. So take the ln pi and multiply the numerator as well. You'll get ln pi squared, but we have the negative here from this negative one, plus what do you have to multiply this with to get this? You have to multiply it with ln x all squared. So you have ln x all squared right there. Now for good looks, I'm going to put this on the front and put this on that side. I have ln x all squared minus ln pi all squared divided by x ln x. Shoot, this is ln pi, sorry. This is ln pi ln x all squared. And that's our answer. That's our final answer.